Assalamualaikum and very good morning. Hi, we are from Group 5 and today we are going to present about our project structure analysis of 6-story buildings. Hi, my name is Siti Julaika binti Jamal and I'm going to present the introductions, problem statement and assumptions. Introduction. Structure analysis is defined as the determination of the effects of loads, physical structure and their components. As we know, the loads was transferred from roof through beam, column, slab, and finally to the foundations. By analysis of structure, the parameters such as bending moment, shear force, and deflection are obtained. This is important as we want to know the strength and the stability of the buildings. Also, in this project, the task was given by the client with the client see to the report and extensive analysis of the structure under various Eurocodes or provisions and load combination of several subframes analysis. The building is proposed with 2 Eurocode with load case 1.3 GK plus 1.5 QK and 1 GK plus 1 QK. We use two Eurocode with a different load case as we want to know which one have a economical value and suitable for the structure analysis. Also, in this project, we use software to analyze the structure. The software that we use is SAP 2000 and LIMPRO. And we compare the value in the software with our manual calculation. Problem statement. This problem statement was there in our task, which is we need to analyze the structure of a commercial center which consists of a 6-story building of about 40 meter long and 18-meter width. Also, the client demands an open plan office and a maximum amount of natural light. For the point 3 and number 4, I already explained in the introduction, which is different of a load case. We need to define it. We need to determine which one have a better economical value and also suitable for this structure analysis. Assumption. Assumption is important as to make our structure analysis more simple. So in this assumption, we assumption on material and distribution load. So first, by considering the value of E, which is modulus of elastic, which the value is a constant for all members and assume the value of E equal to 200 GPa. And the value of I is referred to beam and column size for all members, and the density of concrete is 25 kN per cube. For the I, which is inertia of moment, we use formula BH3/12. For the frame, we assume it as a symmetry. In the symmetric condition, we only calculate on one side. For the other side, we use same value, but the difference of the rotations with different signs. For finding the moment of each cut section, the positive moment is clockwise and the negative moment is the counterclockwise. Moreover, for the structure, the load is only considered for static loading.
So next, we are going to make a calculation about the frame. First, this is our structure, frame structure, which is at the front view. So this is ground floor, first floor, second floor, third floor, fourth floor, fifth floor, and this is a roof. So before we start the calculation of the frame, we need to know what is type of the slab, which is one-way slab or two-way slab. So we're going to this calculation. So this is the calculation how the distributed load at the each of the beam. So this is a plan view. So in order we want to know whether it is one-way slab or two-way slab is by dividing the longest span divide by the shortest span, which is 9,000 millimeter, divide by 4,000, we get 2.25. And this we can conclude this value is larger than 2. So this is one-way slab. So this is our load of area load of our group have been assigned 2.5 for the ground floor and first floor. For the second floor is 1.5 and for the roof is 0.75. So this is a safe way. So next we to calculate the distributed load. So this example is using the Euro code, which is 1.5 QK plus 1.35 GK. So and we calculate all this by using the factor of Euro code that have been assigned. So we get the ground floor and first floor is 12.64 kilonewton per meter. Second floor is 9.64 kilonewton per meter, and third, fourth, and fifth floor is 5.14 kilonewton per meter, and the roof is 7.38 kilonewton per meter. So we done about the calculation. So this is our 3D structure, how it look like. So we display the load that have been assigned at the outer part. So this is our load that have been assigned. So like we calculate, so we distributed of each beam for the each case for the roof, for the ground floor, first floor, third, fourth, fifth floor. So this is how the load looks like. For the manual calculation, we are using moment distribution method, which is the subframe analysis. So next, we are going to know how the manual calculation that have been. So this is how we get the discussion for calculation for the ground floor. So like the moment distribution method, we calculate the fixed end moment at the member A, B, C. So we get this and we solve it until get the last moment. So we calculate all of this RL and RM, so we get the reaction at each member, and so we plot it and get, so we can compare for the manual calculation and 3D calculation. That's how we calculate the frame analysis.
Yes, Assalamualaikum and a very good afternoon to all. My name is Muhammad Firdaus bin Samsudin and my matrix number is 197050. Okay, so I will go through for the result and comparison. For the first one is we are using Eurocode with the factor of safety is 1.5 QK for the live load and 1.35 GK for the dead load. So as you can see, this is the table of result for the ground and first floor, second floor, third, fourth, fifth, and the roof floor. So there is a different value of the N and W respectively according to the floor. Okay, next. We are also calculate for the percentage error between our manual calculation with 2D structural software analysis and 3D software structural analysis. So by the calculation, we can get the result as you can see. For sure, the percentage error between 2D structural analysis and 3D structural analysis software is not to contradict, which for the roof floor, there is only 0.18%, and for the ground floor is 0.39%. But for the comparison between the manual calculation with the 2D structure analysis and 3D structure analysis software is quite contradict. Maybe there is a few calculation that cannot be prevented. Okay, next. The second one, we are using the different Eurocode, which is 1.0 QK and 1.0 GK. So the table of result, as you can see, I present it ground and first floor, second floor, third, fourth, fifth, and the roof floor. Okay, next. This also we are calculating for the percentage error, and we get the percentage error between the 2D and 3D structure analysis software. Just a small value, which is for the roof, we get 0.15%, and for the ground is 0%, which means that we get the value, the result is this exactly same. Okay, next. We are going to the graph that comparison between the 2D frame analysis for the different type of Eurocode used. So for this, we can see that there is a difference in this bar graph between the Eurocode 1 and Eurocode 2. This is because we are using a different factor of safety, as I mentioned before, that will affect the distributed load also. And it will result at the end is for the moment shear. So that's all from me. Thank you.
Hi, my name is Nur Shazwani binti Sani. My metric number is 197248 and I am from group 5. So in this project, we recommend to use software rather than manual calculation to get a better result of analysis. This is because the software is a flexible modeling environment and the density of the concrete can be included. For the manual calculation, we suggest and we recommend to use moment distribution method rather than slope deflection method to save more time, and the calculation will be much shorter. So for the limitation that we have found, the structure has a huge number of degree of freedom and also a huge number of the members of column and beams. So the equation of moment will be difficult to be solved. Second is for the software. SAP 2000 software cannot include the elements and the type of materials. So for the conclusion, for all our calculation and analysis is to help get a better result. As an engineer, we have to get a precise, a high quality model to satisfy our client request. We use SAP 2000 version 16 software and also manual calculation to analyze the structure. While we're conducting this report, we also able to improve our knowledge and understanding in structural analysis. Also, we get more knowledge in application of structural analysis. So, thank you.